This research was part of a stream that was motivated by a desire to improve scheduling in certain healthcare applications and manufacturing processes. And it was conducted jointly with Leo Lozano and Mike Magazine at the University of Cincinnati. My name is George Pollack, and I am a professor in the Department of Information Systems and Supply Chain Management. This research solves a problem in scheduling, and it's called the paired task scheduling problem. And a typical example comes up in a hospital emergency department, where an attending physician has to do two sequential tasks. First, the physician has an initial visit with a patient, and then typically sends out for tests, and then has to wait until the tests come back until doing a follow-up and disposition meeting with the patient. So in the interim, while the physician is waiting for the tests, he or she has to decide whether to move on to another patient or simply to wait for the tests and go on with the first patient. We found that this problem belongs to a class called NP-hard, which means that it is a very difficult problem to solve computationally to optimality. And in fact, there's a general thinking that there is no efficient algorithm that exists to solve a problem in the class NP-hard. Our desire was to push back the frontier of solvability. We formulated a mathematical model and came up with an algorithm that gets very good results in terms of the number of problems that it can solve to optimality. The key takeaways from this research are that a methodology called decision diagrams is very helpful at attacking these problems. Decision diagrams allow us to conduct a divide and conquer approach to this problem. We're able to solve the problems for individual patients or jobs with the decision diagrams quite efficiently. And then we compile or we compose the decisions for the whole set of jobs together using integer linear programming. And the second takeaway is that the decision diagrams are they show likely promise for solving a broader class of problems, for instance, scheduling with more than two tasks. This paper will be published in the Institute for Industrial and Systems Engineering Transactions, and it will be available on the Wright State Rajasona College of Business website.